Welcome to Hope Academy. My name is Mr. O, and today I'm going to be explaining to you how to go about doing the one proportion z test. And how do you identify specifically that when you're given a problem like this in front of you, that it is specifically a one proportion z test. And along with explaining more in depth around the significance values and what does that exactly entail. And so I'm going to go ahead and read the question to you and then explain more in depth. So the Pew Research Center also claims that 87% of internet users who ever use maps or get driving directions do this online. A map publishing company believes that not that many use maps and driving directions online. In a random sample of 250 adults, 83% say they go online to get maps or driving directions. At alpha equals to 5%, is there enough evidence to reject the researcher's claim? At alpha equals to 10% level? So when we are looking at this question specifically, the first thing that told me right off that this is going to be a z-test is the fact that this is this value right here. This is aka my population value right here. What this is telling me is that for certain, I have a population value that I could use that could actually help me get to the standard deviation value, which will entail variance. And so in general, whenever we are able to find a standard deviation value or a variance value based on population, it means that I am able to prove that this is going to be a z-test. If I am not able to prove this fact that this sentence alone is missing, but everything else is available on this, then this would have been a t-test. But for today, we know that this is going to be a z-test. So that's the first thing I did want to point out. Afterwards, the goal is that I'm going to go through the general procedures for the hypothesis testing for specifically z-test. If you want to watch the prior other video, I do have a video on confidence intervals that are relevant to proportions, but this is specifically towards testing to prove the alpha value. And so I'm going to go ahead and get started. So step one. As usual, my first step in this problem is that I must provide a null hypothesis and an alternative hypothesis. My null hypothesis is the assumption almost always that there is no change, while alternative hypothesis mean that there is going to be some sort of change. And so I'm going to go ahead and identify what would that be. When doing the first problem, at least for me, when I'm looking at this question, the thing that is telling me what I need to do is that I need to identify my true proportion. And so in this question, my true proportion is going to aka be P, and I'm going to identify it as P equals to 0.87. Why do I specifically say 0.87? The main reason why is because it's my population value I'm trying to prove whether or not they actually believe that not that many users actually use it or whatever not. That not up to 87% of people actually use it. And so this is going to be aka my null hypothesis. But when it comes to alternative hypothesis, what they're trying to prove, and they're trying to prove that this is not how many people use it. And so I'm going to say my true population value, P, aka the 87%, is actually going to be less than 0.87. And so that concludes my first part of the question. Sometimes for me, I also like to do is include that P equals to just the true proportion of internet users. Whoever, and if you notice right here, I'm copying by verbatim or literally word by word the definition that they provide on the word problem. This prevents me from making any mistakes or get docked any points on the AP statistics exam. And this will help you a lot just to make sure you're doing the work right. And that concludes my step one. Step two. The important things about step two is that it's almost procedural, that there are specific conditions you must fulfill dependent on the specific test. For specifically one proportion z test, I usually mention SRS and I check it off. So what SRS means is a simple random sample. And usually that also entails that it's independent, the test. Just usually you don't need to mention this, but personally for me, I don't want to rememorize it or forget it just in case of points purposes, and so I usually mention that. But there is a specific thing about proportion test that you must also include, is that the NP has to be greater than or equal to 10. or actually no, it's actually just equal to 10. I'm just thinking about it a little more. And that in Q has to be greater than 10. And so what does that mean? Well, my n is the sample size of whatever I was testing. And I should put little hats on this. And so what that means that this n value is going to be 250 adults. So n is going to be 250 for this case. And P is going to be my proportion of people that are actually, doing this thing, which is going to be 0.83. So right here, it says 0.83 from their sample are going to represent that. And that's what P hat means. P hat literally means the sample of the true proportion, or the sample of what you are testing for. And so on the calculator, I could confirm that 250 times 0.83 is going to be the value, 207, which is going to be greater than 10. Perfect. So the next part right here below, I mentioned also n is going to be 250, but for Q, it's going to be 1 minus 0.83, aka 0.17, because Q hat represents the complementary, or aka the other component of P. So whatever the people that did not use it, or whatever not, the separate portion of the 100%. And so if I do 250 times 0.17 is still 42.5, which is still greater than 10, and I'm good from here. And so I could check off both of them. I'm good, I'm good. And that concludes my step 2 procedures. Step 3 will always be the calculations. And so for specifically proportion z test, my z value, or what I'm testing for, is going to equal to z value equals to, well, now I have to think about the specific values that I'm using and whatever not. But usually the z test will involve me doing the observation minus the mean over the standard deviation. And I do want to break this down. My observation, aka is just like whatever is observed for the question, minus the mean, the true mean. So for this question, my true mean is going to be 0.87. And it's going to be over my standard deviation. So standard deviation for this question, and I should write this will be my mean. And I'm going to move this up to show standard deviation for these tests are always going to be the square root of PQ over N. Okay? And so whenever I do the observation minus mean, and I'm going to write this all out so you could use this in reference to it, over standard deviation, I need to plug these specific values in. So my observation is going to be what is observed in this question. And so what's observed in my question actually is going to be this specific value. 0.83 is my observation because that's what I surveyed. I surveyed people and I found out, hey, that's how many people actually believe this. And so that is going to be my observation. So I'm going to put z equals to 0.83 minus, well, I said my mean is going to be 0.87 over the PQ over N. So basically it's going to be my proportion values. It's going to be 0.83 times 0.17 over 250. And I'm going to clean that up right now. So 0.83 and I'm going to put it down here so you could see me doing the work. 0.83 times 0.17 divided by 250. I'm going to square root that whole thing so that I don't mess up any of the values. And it's going to be exactly 0.0238, assuming. So I could write this down and I'm going to just show it so it's easier for you to follow. So it's going to be 0.83 minus 0.87 over 0.0238. And that still equals to my z. And so I'm going to do 0.83 minus 0.87 divided by 0.0238. Voila. So it'd be negative 1.680 like 7. And I do around 4 decimal points. You could do 3. It's just that it's more accurate that way if I give a little bit more. And so my preference is around 4. And then this is my final answer for the step 3. So I'm going to move that up. And what does this mean? What does that negative 1.6807 mean? Well, in the z-test, if you remember or if you're reviewing this, it represents the amount of standard deviations away from the mean, aka the normal amount, the normal curve that exists. And so this represents that literally from the center of this normal curve that exists, it's going to go negative from this, negative 1 negative, or aka just 1.6807 away from the center, and it's going to represent that my standard deviations away from the mean. Okay, and so that's just something to know, and it's just a side note for you to follow. But that will conclude my step 3. Afterwards, and just to continue, I'm going to use a separate piece of paper just to continue on this. So the next step is going to be step 4. And step 4, usually for me, it's the idea that I'm converting this, this value into a p-value basically. Because z-values, I don't know what that means exactly. I don't know exactly what that means in relevance to alpha, which was mentioned above. And I'll reference back to it again in a bit. But because I don't know what it represents, I need to convert it to a p-value so that I can interpret it right afterwards. And so what I'm going to do is that I'm going to write that p when z, and this is me trying to test whether or not this is true or not. And it says that less people use it. So if it's less than negative 1.6807 equals to, and this is where the functionality comes in. And so I'm going to write down the functionality also, but I will also show you how to go about doing the computation. So on stats, I'm going to push... not stats. I'm going to push distribution right here, and I'm going to go to normal CDF. Okay, so I'll write the functions or the steps on the paper too, but just follow along for now. And I'm going to put negative 999, comma the z-score that I got negative 1.6807, and I'm going to get this specific p-value. So it is let's bring that back, 0.0461. Okay, and so that means there's a 4.6% chance, or the p-value is 0.0461 chance that actually is going to go lower than that value and whatever not. Okay, and and that's where step 5 will be me interpreting this. But before I continue, I will write down what my steps were on the calculator for specifically TI-84. So what I did was that I pushed second. So I pushed the button second, and I'll draw a little box just to show second, and I'm going to push the button that says vars on it. So second vars. So I'll show that one more time, second vars. So I'm going to go ahead onto the calculator and push the 2 normal CDF. Afterwards, I'm going to put negative 999 into here. So I'm going to punch in negative 999, comma, the z-score. And I'm going to explain why I'm typing specifically negative 999 and then the z-score. So because the question is relative to me going left right now, I intentionally do is I put negative 999. What it does is that it forces the calculator to go leftwards. And so afterwards, what this does, because I'm testing for proportion that's below it, I'm going to put comma z-score. If the question was asking me if it was greater than or higher than, what I would actually do is write z-score first, or type down z-score first, comma 999. But because of this scenario, it makes me do this format. And so that's where I got this value. Afterwards, step 5, the very last step to this whole procedure. Step 5 is my conclusion. Basically, it's explaining, because of this percentile I got 0.0461, what does this exactly mean? And this is what it exactly means. So looking at this and looking at the alpha value that was mentioned before, and I'll bring it back down. Okay. It says at 5% value, is there enough evidence to reject the researcher's claim at the 10% value? What this means is that if my if my p-value that I got from this whole test is below 5%, I can reject it. If it's not below 5%, I fail to reject it. There's never, I accept null hypothesis. I fail to reject null hypothesis, or I reject null hypothesis. And so just because this is a statistical sort of framework or the procedural aspect of it, I'll say that rather than saying with, I'll write down since my p-value, and this is going to be 0.0461, it's less than the alpha at the 0.05 level, we can reject the null hypothesis and state that there is, and duly note that I am actually right here going to copy this little this statement, that there is enough evidence to reject the researcher's claim. So I am going to write down that. That there is enough evidence to reject, and I could be more detailed and I will do that. Reject the researcher's claim, and I'm going to elaborate on this. Claim that 87% of, and this was from the problem 2, internet users who ever use maps or get driving directions do this. Ooh, I'm going to bring it up. Online. Okay, and so that concludes my explanation as to how to go about doing the procedure and how do you go about getting a conclusion and your explanation and whatever not. And so be aware that there could be subtle differences on the AP statistics exam as to how they explain it, just like specific word wise, but this would in general get you the full points for the AP statistics free response portion. And before I go ahead and continue and conclude this, I do want to also explain how to do this on the calculator. So specifically on the calculator, the important thing you must understand on this calculator is that the values, you could get the almost exact value as you did on the calculation here. You do have to note, I do have to note that when I'm using the calculator functionality, actually the answer that comes out of this calculator in order to get the p-value will be more accurate than what you do on paper. As long as you show the work on the paper and you do it properly here, it's perfectly fine. There is round off errors that do exist along with certain limitations that might exist on the calculator. But I do want to go over how to do it on the calculator. So on the calculator, what I first did was I pushed stat right here. Stat. I'm going to push the left key right here. I'm going to go down to 1 proportion z test because this is a test, not a confidence interval. So I'm going to push enter, and it's going to give me these random values that are all zeros right now, as long as you didn't input anything before. Feel free, the P0 thing is going to represent my true proportion value, aka for this question is 0.87. The X is going to represent my actual value of sample. So for this question right here, I don't know, my value actually states right here, and I'm going to bring the question back down so you can follow along. The question actually states right here, it is 83%. I cannot put a decimal value here. It actually wants the fraction value out of the total sample, which is 250 to represent what X is. And this is what I'm going to do. So I'm going to turn it off. I'm going to put 0.83 times 250, and I get 207.5. The big problem with the test for this calculator is it actually cannot do decimal values. So I have to round up or down near it. So for example, I'm going to choose 208 because I feel that 208 is about, reasonable. There might be some differences and whatever not, but I'm going to put 208 or out of 250. And for this part right here, I'm going to change it to less than, because for this question, we're actually testing for less than, as is mentioned in the null hypothesis right here. And I'm going to calculate. Right here is my p-value that is mentioned. It says it's actually going to be 3.7% rather than what I got right here, which is 4.6%. It's fine to have a little bit of error. It's bound to happen. But the conclusion will still be the same in the end. That based on the alpha equals to 5% value, I am able to reject the null hypothesis, which is also going to bring about another question. If you notice right here, it also asks you at the 10% level. If I'm able to reject at the 5% level, I'm able to reject at the 10% level. And I must emphasize that fact, because as long as you're below the alpha value, you can reject. So if I've succeeded here, I succeeded here. And so this concludes my explanation for today. Feel free to leave a comment below to let me know if there's any concepts that you want me to cover, and I'll do my best to do so. Please do subscribe to our YouTube channel or like our Facebook page just to keep updated on new videos that I'll be bringing out, and I hope you have a wonderful day.